I'm going to do several problems from the homework today, specifically 4 of them. I'm going to start with problem number 2. So this is on page 386. You are assigned 2 through 20, all evens. And I want to do number 2, number 8, 14, and 20. So this is a section of using substitution to solve systems of linear equations. Number 2 gives you a pair of equations. And here they are. 2x minus 3y equals to 24, and 2x plus y equals to 8. And number 2 doesn't ask you to solve them. What it does ask you to do is tell them which equation would you solve for and which variable would you choose. So in substitution, when you have 2 equations, you want to choose the easier one to solve initially. And the easier one to solve for initially is the one on the right. Why? Because you have a y that has a coefficient of 1. Essentially, it doesn't have a coefficient, so to speak of. So it's very simple to solve for, and the variable that you will choose is y. Because all I have to do is subtract 2x from both sides, and y is now all alone through one single step. On the equation on the right, no matter which variable I chose, it would have to be a 2-step process, because first of all, for example, if I chose y again, I would have to subtract 2x from both sides, then I have to divide everything by 3. If I chose x as my variable, I would have to add 3y to both sides and then divide everything by 2. On the equation on the right, if I chose y, I simplified and get it to a form where the variable is isolated through a single step. So y and the second equation is the one that you want to use. So that was number 2. I'm going to go ahead and move on to number 8. So number 8, we're actually going to do a substitution. So we have 2 equations. That's the first one, and the second one so in a lot of cases you will have both equations that do not have the variable isolated. In number 8, it's very simple because in one of the equations the variable is already isolated. In the second equation, it's in the form of y equals to. So y is all isolated, all ready for you to go. So they already made the choice for you. So you are going to substitute the second equation into the first one. So you're going to substitute the value of the y, which is this, into the first equation right over here. So you're substituting y for y, or specifically the value of y in there. So this is what it's going to look like after you perform the substitution. Now all you have, and the x over here. So now the y is gone, all you're left with are just the x's. Perfect. Now you can actually solve this to completion. So first step is to distribute the 3 to both members of the parenthesis. 3 times 10x is 38x. 3 times negative 8, that's a negative 24, equals to 51. Then you combine your like terms. Negative 5x plus 30x, that's 25x, minus 24 equals to 51. Then I'm going to add 24 to both sides. So 25x equals to, and 51 plus 24 is 75. My last step is to go ahead and divide everything by 25. When I do that, 25 divided by 25 simplifies to 1. Sorry. And x is 75 divided by 25, which is 3. Now we're not finished yet. We just got the x, and we need both ordered pairs. So we need x and y in order to get a solution. So now we just got the x, so we need to find the y. So to find the y, what I'm going to do, I'm going to select either of these two equations and substitute my value of x, which is 3, into them. Again, it doesn't matter which one you choose. I think the second one looks simpler, and that's the one I'm going to choose. Again, you could have chosen either one and it wouldn't make a difference, except one would be a little bit simpler to solve. So in this equation, I'm substituting 3 for the x. So it's going to be 10 times 3 minus 8. So everything else is the same, except I substituted 3 right here and for the x. So y equals to 10 times 3, which is 30, minus 8, and y equals to 22. So x was 3, y is 22. My ordered pair is 3 because x goes first, 22 because y goes second. Done. And if you wanted to, you can plug them back into both equations, both the x and the y, and it should perfectly work out. It should check out. I'm not going to do that, but you're welcome to do it on your own to make sure that your work is correct. So that was number 8. I'm going to go ahead and move on to number 14. Number 14, you have, again, two equations in a system with the same variables, x and y. Doesn't always have to be x and y, but they are definitely the popular kids on the block when it comes to variables in math. In this case, none of the variables are isolated. So you would have to isolate, you would have to choose an equation, isolate a variable, and then do the substitution. Doesn't really matter which one you choose in this case. I think the first one just looks simpler. X plus y equals 0. It's pretty simple. So I'm going to choose, I want to work on that one. So I'm going to rewrite it right here. X plus y equals to 0. Then I'm going to solve for x, because x is just all alone here without a coefficient. It's just going to make it easier when I do the substitution. So I'm going to solve for x, which means I'm going to take away y from both sides. X equals to 0 minus y, or a negative y. Then I'm going to take my negative y and substitute it for the x here. Since x equals to negative y, I can just put it right over there. Substitute it. Alright, now I combine my like terms. Negative y minus 2y, so I'm going to get a bigger value of y, a negative 3y, because there's a negative 1 in front of the y that's hidden. And then I want to isolate y by dividing both sides by a negative 3. It's gone on the left side. Negative 3 divided by negative 3 is a 1. And y equals to 6 divided by negative 3, which is negative 2. So that is the y value. And as always, we need an ordered pair. We need both the x and the y. So the way I'm going to do that is I'm going to take this y equals to negative 2 and plug it into one of these two equations. Doesn't matter which one I choose. I'm going to go ahead and choose this one. Again, because it's just easier. I'm going to rewrite it right over here to save some paper. X plus y equals to 0. I know what y is. It's negative 2. So I'm going to substitute it in. Plus a negative 2 equals to 0. Then I want to isolate x. I'm going to add 2 to both sides. X equals to a positive 2. So my order set is x2, y is at negative 2, and I'm done. So again, you can always plug both of these in here. You can actually do that very easily for the first equation. If x is 2 and y is negative 2, 2 plus negative 2 is 0, 0 equals to 0. And you could do that for the bottom one as well, and it should work out. But we don't have to. The book isn't asking us to check our work, so we're not going to. So the last one that I'll do is problem number 20. Alright, so number 20 again, so 20 here gives us two linear equations in a system, and we're going to solve it through substitution just like numbers 8 and numbers 14. Again, none of these are isolated, so you have to choose one, isolate the variable, and then substitute that into the other equation. I think the bottom one looks simpler. Actually, in this case, the top one looks a little better. They're both equally good, I'd say. I'm going to choose the top one. I'm going to work on the top one. You could have chosen the bottom one here. It really is not going to make much of a difference. And I'm going to isolate the y because it's already all by itself, so that should make it a little easier. So I'm going to subtract 6x, subtract 6x. That's gone. Now I have y isolated, and I'm going to substitute this value in for the y in my second equation. So x minus 4 times this equals to 19. Alright, that's done with. Now we have to open up this parenthesis by distributing. X minus 4 times 4, 16. Then minus 4 times minus 6x, so minus times minus, that's plus. 4 times 6, that's 24, so 24x equals to 19. Combine my like terms. So x plus 24x, 25x minus 16 equals to 19. Then I'm going to isolate x by removing everything next to it, starting with the minus 16 using reverse operations. Gone. So 16 plus 19, that's going to be 35. If my math is good. Yeah, it looks right. And then I'm going to isolate x by dividing both sides by 25. It's not going to come out even. Of course, being number 20, it's going to make things a little bit more complicated for us, but it's okay. Now 35 and 25. So 25 is not going to go into 35 even, but they both will simplify down because you can factor out a 5. So it's going to be 6 over 5. So that's going to be the x. Alright, good. Not a problem. Now let's go ahead and substitute this into one of the other, or any of the equations. Doesn't really matter. I'm going to substitute it in right here because the x is all by itself. That's going to make it much simpler to work with. So I'm going to rewrite that particular equation. And then I'm going to substitute the 6 over 5 in for x. I know it's a fraction. It's okay. We'll make it work. So now we have to isolate y by removing everything next to it. We're going to get rid of the 6 over 5 first by subtracting the 6 over 5 from both sides. So we get negative 4y equals to 19 minus 6 over 5. Now I want to simplify this, and the only way to do that is to convert the 19 into an improper fraction. So 19 is the same thing as 95 over 5 because 95 divided by 5 is 19. But now I will have a common denominator to work with. So 95 minus 6 is 89. So I get 89 over 5, which also does not simplify. So they're making our lives just a little bit more difficult. Next step would be to get rid of the negative 4 by dividing both sides by negative 4. It's being multiplied, so that's why we do the opposite. And yes, you're going to divide that fraction by negative 4. That's gone there.